You mentioned earlier the chronic diseases. If you
Yeah.
look at in the United States or industrialized societies in general, the number one killer, people die the most of heart disease,
Yeah.
some sort of heart disease.
Yeah.
And obviously lots of different things regulate our susceptibility to heart disease, and
Yeah.
metabolism, obesity. But you found some very interesting findings doing time-restricted feeding in fruit flies.
Yeah.
So can you talk a little bit about that? I'm very interested in
So fruit flies are used in science for many years, and they have a short lifespan. They stay alive maybe 9 to 10 weeks max. So it helps us to figure out whether any intervention like time-restricted feeding will have any positive or negative impact on health span or healthy lifespan or longevity, etc. Mm-hmm. So what we did was, again, a very simple experiment. We took fruit flies and we gave them food only for 12 hours during daytime, because fruit flies are diurnal animals. They fly around during daytime, eat, and then nighttime they sleep. Or they had access to food for 24 hours. And we measured that they were eating the same amount of calories, and they were also moving around the same distance. So inside these bottles, they could fly back and forth. Mm. And at 3 weeks of age, the heart is very healthy. It beats rhythmically. And although the fly heart is not like human heart, they also have...
Those people are probably shocked flies have a heart.
Yeah. So their heart has very similar genetic program. In fact, many of the genes that are now known to be necessary for heart development in human were discovered in flies. And vice versa, there are many diseases in humans. Those are now put into flies to see what do they do in the heart. Mm-hmm. So it's a very interesting model. Just like humans, the fly heart also becomes weaker with age. So by 5 weeks, the hearts don't beat rhythmically. They have a little bit of arrhythmia, and then they have the same dialysis. So the heart gets dilated with age. The beat-to-beat distance also becomes very irregular. So what we found was when these flies eat only for 12 hours, they don't develop that arrhythmia as quickly as the normal flies do. So they're protected from this heart disease. Then we said, okay, so if we introduce time-restricted feeding later in their lifespan, then what happens? Because one thing we could not do in mouse study, because mice live for 3 to 4 years, we could not introduce time-restricted feeding later in life. But in flies, when we introduced later in life, they were also protected. The arrhythmia reduced in flies. And when we gave high-fat diet to flies, they also produce arrhythmia and many heart conditions that we see in humans, and those were also protected in flies. And what is interesting in flies, we also saw the flies sleep better when they eat only for 12 hours. So by 5 weeks, flies actually are just like very old people. They have fragmented sleep at night time, and they're sleepy during daytime, and that is completely prevented by time-restricted feeding. They have a good night's sleep. They're very active during daytime. The heart pumps nicely.
Wow. Did you measure heart rate variability? Or?
Yeah, so we did heart rate variability. So there are 7 different parameters we measure.
And that improved?
Yeah, so all those 7 parameters improved to some extent. And when we introduced later in life, they also improved. That was the surprise.
Do you know what or why?
Yeah, so what we found is, again, one connection was back to mitochondria. What we found was that mitochondria were healthier in the sense maybe they were not producing as much reactive oxygen species.
The mitochondria in the cardiomyocyte, in the heart cells?
In the heart cells.
Okay.
So we took the heart cells and did gene expression profile. We looked at all the genes. What we found is there was a big cluster of genes whose expression actually reduced, and those are from the electron transport chain. So that implied that maybe they have less reactive oxygen species, or maybe reduced activity of ETC, electron transport chain, is beneficial. So then to prove that, we actually knocked down few components of ETC, and those flies also have better heart. So that was one thing that we found.
Interesting.
Second thing that we found is proteostasis, or protein folding, is necessary, and in many other organisms, people have shown that in different components of protein folding machinery. But here, what we found is there is a new protein folding, very newly identified folding machinery called ATP-dependent. It's a chaperonin complex. 8 different components form this barrel-like structure to fold proteins. And this requires energy. And that CCT component has been shown to be important for various cytoskeletal protein folding. And it makes sense for heart. And in fact, in humans, there is a point mutation in one of these CCT component that has been shown to predispose to some heart disease. So it's a beautiful story where we found both mitochondria and this protein folding machinery are necessary for this time-restricted feeding beneficial effect.
And this time-restricted feeding was 12 hours?
That was 12 hours because flies are different from us. They don't have thermoregulation. So when they fast for a longer time, they cannot. They can't tolerate that.
Oh yeah, they'll get cold. Okay, yeah. So some of these phones also measure heart rate variability.
So it'll be
interesting. Very interesting because that's like, that's something that's supposed to be very important for having a healthy heart. But if you don't mind, again, this is it's another reason why this time-restricted feeding. It just seems like everyone should be doing it. It's an easy lifestyle adjustment. I mean, easy enough. You have to be disciplined to some degree, but it's easy enough that you can do. It's like, by the time it's 12 hours later, all right, that's it. You got to make sure you get all your food, your whatever it is that you consume within that